Hello and welcome. Introduction. Now, in my previous video, that is part one of this video series on FreeRTOS or RTOS, I show you how to set up, in that previous video, I show you how to set up FreeRTOS in AtMel Studio 7. Now, this video is a continuation of that. So in this video, I will discuss how to use FreeRTOS to create a task to blink an LED. So we will be writing some code. Creating one task. All right, so we start off with the familiar include directive. This first one here is by default. The AtMel Studio 7 will generate this when you start a new project. So the avr/io.h. Now followed by these two include directives. The first one is FreeRTOS.h and task.h. Now you need these two in order to work with FreeRTOS. Now next follow these two declaration or two functions. We'll come to the details of these two functions very soon, especially this one. Okay, so then follows the main function. Now in the main function, the first line here is to declare, or rather to fix the data direction register of port D. Set it up as an output port, and then we have the while loop here. Inside the while loop, we have X task create and V task start scheduler function. Well, again, we'll come to the details in a few moments. Next comes the actual definition of the two functions as we mentioned earlier. So this is the avoid application ideal hook. We'll come to that in a minute. And then the next one, the function is the actual task itself actually. So it's void my task one, and then void asterisk PV parameter. The PV here, it refers to point to void. Basically, this allows the task parameter to receive a parameter of any type. So this is known as the task parameter. We'll come to task parameter in another video. So the task itself is a while loop where we will invert the bit 3. Is this bit 3? 0, 1, 2, 3. A bit 3 of port D. So if it's a 1, it will change it into a 0. If it's a 0, it will turn it into a 1. And a green LED is actually connected to bit 3. A little bit more detail about hardware later on. And then this here is the V task delay. All right, so this is a delay function, and the parameter inside here, this 300 actually tells us is 300 milliseconds. So this whole thing function here is the actual tasks. Now let's look at go backwards. So let's look at the V application idle hook function. Now basically this is a user provided hook function, and it is called, all right, or invoked when there are no tasks to run. Now the purpose of this whole function is to allow user to perform low priority background tasks, put the microcontroller into a low power mode to conserve energy when there is no other processing to be done. Now in our example, we are not using anything to or providing any low priority function background task at all, but we need to include this in the code. If you don't have this in the code, you will get an error during compilation. All right, I'll demonstrate this in a minute. All right, so that's the V application idle hook function. All right, then the next one is the X task create, as we've seen earlier. So there are several parameters in this function. Now the first one is the V task 1. Now this actually is a pointer, so it points to the task itself. In other words, it points to the task that we mentioned earlier. Now this one in quotes, the second parameter in quotes task 1. This is the name of the task. Now you don't have to call it task 1, but in our example we call it task 1. You can call it anything else. Now this is used for debugging purposes. Then the next parameter is the depth of the stack. That means the size of the stack. Then the next parameter, we set it to null. Basically, this is the task parameter, but in our example, we are not using any task parameter. Then next one is this number 1 here. This is the priority number. So this task will run at priority 1. And then finally, there's a null parameter. This is the task handle, right? So in our example here, we are not using this. So hence it's a null. Then finally, we have the vTask scheduler, no, vTask start scheduler function. Basically, as the name here suggests, this starts the RTOS scheduler. Now, after the scheduler has started, the RTOS kernel will then take control which tasks are executed and when, just like we have covered this in our scheduler video series. Now, to test the code, we will need some hardware. All right, here is the circuit diagram or schematic diagram for this particular video. So I have green and blue LED. You may choose any other color that you wish. So let's take a look at the green LED. The anode of the LED is connected to pin 3 of the Arduino Uno. That happens to be bit 3 of the of port D of the Atmel 328P, and then the cathode of the green LED is connected to one end of a 220 ohm resistor, and the other end of the resistor is connected to ground. Now this applies to the blue LED, except that it's connected to pin 5 or bit 5 of the Atmega 328P. And on this side is the wiring diagram of the schematic. Code demonstration 1. Okay, so here we are in Atmel Studio 7. I've uploaded the code. Now, in this demonstration, I assume that you know how to set up FreeRTOS in your Atmel Studio. Now, if you're not familiar with it or you don't know how to do it, can you please, I recommend that you will refer to my previous video on which I show the viewers how to set up FreeRTOS in Atmel Studio 7. So if you are not familiar with it, please refer to that video. So in this video, I assume that you know how to set up FreeRTOS, and I have load up the code here. All right, so which we have discussed this earlier. So I'll quickly just go through this. So here is the default include directive with the avr/io.h. Now these two here, as mentioned earlier, you need to include these two header files, freertos.h and task.h. If not, this thing won't work. Now here I declare the functions that I've used. In fact, the first one is the task. Here we're setting only one task, and then here is the AV application idle hook function. Now, as mentioned earlier, without this, the code will not compile. All right, now to demonstrate this, I'm going to comment this out, and I'm going to just comment this out too. All right, here we go. All right, so let me just save it and then rebuild this code. As you can see, in the error list panel down here, we find that it says undefined reference to application idle hook. Now this is referring to the task.c file. So if I double click on it and we're in there, and you see in task.c file, we find that it's calling this, and we have not included that in the in our code. So let me just close this now. So let me just take this out. All right, okay, go back here, and now we save it, rebuild it again. All right, so that error has gone. Now these are the 4 warnings that we had earlier. Now I will do a separate video to discuss this 4 warnings, but for now we'll leave it alone because we still can run the code. All right, so the important thing is we get 0 errors. All right, so let's get back to the code. So we have seen the effects of this V application idle hook function. So now in the main function here, we set DDRD, that's the data direction register D, to output mode. And here in the while loop, in the main program, we have the X task creating our first task, my task. Then I have the V task start scheduler function, and then here that's the main function. Now here I define the functions of the task that I'm using. Now in this case, our V application idle hook is empty because we are not doing any low priority activities here. So it's okay, we leave it empty, but we must still have it in. If not, as you've seen earlier, we will get an error if we don't have this. Now down to the task 1. Task 1, the function is basically to blink the LED connected to bit 3, and I have a delay here using V task delay of 300 milliseconds. So basically that's the task. All right, so we have already compiled the code. Let's do it again just to make sure. All right, now let me just bring up my camera. Here we have my setup here. Let me just okay, I just want them be side by side so that we can. All right, so now I can go to tools and download the code to the Arduino Uno, and we should see the green LED. Please ignore the blue LED for the time being. We are focusing on the green LED, which is connected to bit 3 of port D. All right, so go to tools, download my code, and we can see the LED now blinking. All right, so I'll just leave it on just for a little bit longer. All right, so that's it for this particular demo. Creating two tasks. So we start off with the usual include avr/io.h, and then followed by these two include directives, the FreeRTOS.h, task1 task.h. And here I declare the two tasks that I'll be using, and then the void v application idle hook function. All right, so what the only difference between this example and the previous one is that I have this second task here, and here is the main function. This line here will make the data direction port D, set it as to output mode, and within the while loop I have two x task create function. This is the first task, and then this is the second task, and the v task start scheduler function. All right, so this is the what's inside the while loop. In here we have the void v application idle hook application function. We're not doing anything inside this function, so it's left blank. We need this, as we've seen earlier in the earlier example. Then this is my first task. This is identical to the previous example. I have an LED connected to a bit 3 of port D, and I'm inverting the LED. If it's a 0, it will switch it to a 1. If it's a 1, it will turn it to a 0. And here is the v task delay function, and this I'm giving it a value of 300, which is 300 milliseconds. Then the second task, I have an LED connected to bit 5 for port D, and here the delay v task delay function, I give it a 1000 milliseconds. That's a 1 second delay. So that is the function of the second tasks. Code demonstration 2. Okay, so we are back in the ML Studio 7, and here we have the second demonstration, the code, and notice that the only difference here is in the don't forget that these are important. So the first one is avr/io.h. You need to include this. Then by default, this is in anyway. So the next two, as mentioned earlier, we need to include the FreeRTOS.h and the task.h. These header files are required if you're using FreeRTOS. Now here we have 3 declarations. The first 2 are the task. We've covered this in the earlier part of the video. This is task 1 and this is task 2. We'll come to the details in a minute. Then the familiar v application idle hook function. We need this. Without this, the program will not compile. Then this is the main function. Now in the main function, ddrd is made into an output mode. All right, it's set to output mode. And then here in the while loop, we create the first task as before. Then we create the second task using the x task create to create the second task, then followed by the v task start scheduler function. So that this one will start the scheduler. Then here is the void application idle hook function. In this case, there's nothing in here as before. As again, let me repeat myself, without this, we will get an error during compilation. Then this is task 1, and we are going to blink the LED connected to bit 3 of port D of the ATmega328P. Then there is a delay of 300 milliseconds using the V task delay function. Here is the second task for this demonstration. Here we are going to blink bit 5 of the ATmega328P port D. And here the V task delay, we assign 1000 milliseconds. That is 1 second delay value. Alright, so that is the second task. Alright, so let's compile. You can either use build or rebuild. Okay. For some reason, it has corrected the warnings, so it's successful. Anyway, I'll explain the warnings in the next video. All right, so but in this case it seems to have corrected it. I don't know why that is, but anyway, so we are good. So once we have compiled this, let us download. Oh, but before we do that, let me bring up my. So here we have the blue LED connected to bit 5 of the ATmega328P port D. All right, this is connected to bit 3. All right, so let me just bring this thing here. So I'm going to download the code. So here we go. Right, now you can see the green LED connected to bit 3 is flashing at 300 milliseconds. The blue LED is connected to bit 5 and it's blinking at 1 second interval. Okay, so that is the second demonstration. Task within a task. Now basically this example that I'm going to show you is a repeat of the second example that we see a few moments back. Basically here we're using a slightly different approach. All right, so here we have the familiar avr/io.h, and then here we have the include FreeRTOS.h, and here we have include task.h, and here I declare the functions that are being used, and the first two are the task 1, task 2, and V application idle hook function. As seen earlier, without this we'll get a compilation error. Now here, this part here is the main function, and here we make DDRD, that is data direction register D, set it to output mode. And here we have the while function. Notice within the while function we have only one X task create function, creating task 1. Now task 2, the function to create task 2 will come in a few moments. Here we have the task start scheduler function. All right, so that's the main function. Here we have the void V application idle hook function. It's empty, as mentioned earlier. Without this, we will get a compilation error. Now, here comes task 1, and within task 1, we are creating task 2. So we'll find we include the X task create function here to create task 2, and then the while loop here, we basically toggle bit 3 of port D at a rate of 300 milliseconds delay. All right, so this is task 1, and within task 1 we create task 2. And here finally task 2 here basically the same as before. We are blinking bit 5 of the port D at a rate of 1000 milliseconds, and that translates to 1 second. Code demonstration 3. Okay, so we are back in ML Studio once again for the third demonstration. Now, this particular demonstration, basically the outcome will be the identical to the previous demonstration, except that the way the code is being implemented. So the idea is to have two tasks as before. Each task will blink the green LED and blue LED, but this time the way that the two tasks is being implemented is different, as mentioned in the discussion. So let's take a quick look. So here here is nothing. In fact, there's nothing new or strikingly different, except for when we come to this a while loop in the main function. All right, you notice there's only one task being created in the within the main function, which is task 1. So we use x task create as before to create task 1, and then we have the v task start scheduler function here. And then we have in the definition, we have the section, we have the void v application idle hook function. Again, we leave it empty. Without this part here, we'll get a compilation error. Now, here comes the first task. Now, in the first task, as you notice, we have a x task create, which create the second tasks. All right, so that's the difference that for this particular demonstration. Then we have the definition of the second task here. So this task, the first task again, is to blink the LED connected to bit 3 of port D. But within the task 1 itself, we create the second task. And the second task is to blink bit 5. The LED connected to bit 5 of port D, and the rate is 1 second. All right, so let me just save it, and then you compile it. All right, so let's now okay, so let's look at the. All right, so we've compiled it, and then let's download it. As before, so you can see the green LED blinking at 300 milliseconds and the blue LED blinking at 1 second. All right, so that's the third demonstration. So that's it for this video. Thank you for watching, and I'll see you in the next video. Bye.